is 2014 problem number 3. There was one theorem that you really needed to know in order to be successful with this problem. Everyone know what theorem that was really helpful? Yes, Paul?
Is it the fundamental theorem of calculus?
It was the second fundamental theorem of calculus, absolutely, SFTC. And actually, for part A, you needed the first fundamental theorem of calculus, right? Which we all know is just the definition of a definite integral. Okay. All right. So the first problem said find g of 3. 3 is your input for g, which means it's an x value, right? So we're plugging the 3 in here, not here, here. So this is equal to the integral from -3 to 3 of f of t dt. So to do the integral from -3 to 3, we get area under this triangle, right? And then here, area of that little triangle. Okay, so the integral from -3 to 2, everything's positive, so it's 1/2 base times height, that's a 4. Okay. Is it plus or is it minus? Why is it minus?
Because it's on the other side.
Yes.
The integral is giving you the displacement, not the area. Like, you have to subtract anything on the curve. It's
Okay.
the change, like the difference.
Yes, I get that, yes. So, when the curve is below the x-axis, it's actually giving you, just so you know, the integral, if you think of it in terms of area, it's doing top minus bottom, right? So anything below the x-axis is going to be negative, so we subtract minus 1/2 times 1 times 2. 1/2, 1 times 2. So we get 10 minus 1, answer is 9. Does that make sense? Yeah. Good? All right. Part B. On what intervals from -5 to 4 is the graph of g both increasing and concave down? What tells us that g is increasing?
Positive.
What's positive?
When f of t is positive.
In terms of g. When g prime is positive, right? So it would be helpful to know what g prime was. All right, so we know g is the integral from -3 to x of f of t, right? So g prime is the derivative of the integral from -3 to x of f of t. Whenever we need to find the derivative of an integral with variables in the limits, we take the top limit, plug it in, times the derivative of the top limit, which is 1, right? Minus the bottom limit, plug it in, times its derivative, which is 0. So g prime is actually equal to f. Alright, so SFTC, very important, big thing to know. So g prime equals f, which means if we want to know where g prime is positive, we're looking for where f is positive, right? Alright, so f is positive wherever it's above the x-axis. So f is positive from -5, from here to here, right? So anywhere in there. But then it also has to be concave down. So concave, how do we know when something's concave down?
Slope is
Second derivative is negative, right? So we need g double prime. G double prime is equal to f prime. We want to know where this is negative, so we're looking for where f prime is negative, which means where is the slope of f negative, right? So what we're looking for is where is it above the x-axis, but decreasing. So our answer for part B would be -5 to -3, union 0 to 2, because it asked you to give a reason, right? We always do because statements. Because. Don't make up your own. Everyone who makes up their own always messes it up. Go with the canned statements. They will always work, right? We're talking about g. G is increasing because g prime
is positive.
greater than 0. Okay? G is concave down because
G double prime
Never said
is
so.
less
is
than
less than 0.
I think it uses the integral.
Alright, now, if you want to interchange, like say G prime, which is equal to F, right, that's fine. If you want to say G double prime, which is equal to F prime, which is less than 0, right, you can call them F, you can do it in terms of F, you can do it in terms of G. You could say because F, which equals G prime, is decreasing for the concave down, but be very careful that you say the right thing is decreasing. So that's an easy trap to get caught in. So be very careful about that. If you use the canned statements, you're safe, right? So this is one of those times where conformity is good. All right, part C. So the function h is defined by h of x equals g of x over 5x. Find h prime of 3, so we need h prime of x. Ooh, what rule do we have to use?
quotient rule.
Quotient rule. For quotient rule, do we differentiate the top or the bottom first?
Top.
Top, right? All right, so g prime times 5x minus g times 5 all over 5x quantity squared, right? Okay, and you can clean it up if you want. I canceled a 5 from every term, so you get x g prime minus g over 5x squared. We want h prime of 3. So plug in a 3. G prime of 3 times 3 minus g of 3 over 5 times 9 is 45. Okay, g prime of 3 is the same thing as f of 3, right? So, f of 3. Now, never assume, just because it looks like it's -2, that it's -2. Once in a while, the College Board likes to do funky slopes where it looks like it's -2, but the slope, like here, you went down 8 over 4, but once in a while they do like down 8 over 3 or something, you know, just to mess with you, right? Yeah, so make sure you take the 2 seconds and double check that this point really is there. This one it is, right? Down 2 over 1, down 2 over 1, down 2 over 1. Yes, we're at -2. But always double check, yes.
I believe you made a mistake for the h prime, because so you had 5x squared, shouldn't it be 25x squared?
Oh, I canceled a 5 from every term?
That's so close.
Well, okay.
Okay. All right. So, we get -2 times 3 is -6 minus g of 3. Ooh, g of 3.
No problem.
9? How'd you get 9?
I went to A.
He's a
We
genius.
found it in part A, right? Okay. Now, there's another lesson in this. Two lessons, really, right?
Don't get the
Oh,
first
whoops, I
part
don't know
wrong.
I can make it. Okay. Whatever you put for this answer, as long as you take that and transfer it here, right, you get the credit, even if this is wrong. Do y'all understand that?
Yeah.
Which is why it is so important, I cannot emphasize enough, that you never ever leave any parts of any free response blank ever, right? If you don't know any idea of what you're doing for g of 3, like you're sitting there and you've never even seen a function before, right? You're like, I don't know what g of 3 is. Pick a number in the world and write an answer so that you can use it when you're doing this, right? Because you could do this. Yes, sir.
Wait, so if you get the first part wrong, and then when you're doing this, like the C part, do they like grade based on like your first part? So
Yes.
then like you won't get the answer for the third part wrong either, so you'll get right.
If you get the first part wrong, but you take the wrong numeric answer and use it here,
Oh,
you
but if
get
you use the right
full
one,
credit.
if oh yeah.
Yes. So they will not double jeopardy. As long as it's like just a numeric transfer. If you had to find a function here, and you had to use a function here, and you would change the function, they're not real nice about
But then like your answer for the C would be like wrong. Would you still like get the points for
Yeah,
it?
you still get full
Okay.
credit. As long as it's correct based on your answer from
Okay.
part A. Yes. So anyway, this is fine, right? Numerically equivalent to correct is correct, right? Happy. Okay, that's it. But anyway, so, okay, so anyway, it's negative of 3. Okay, so, all right.
How'd you like it?
Last part, P of X.
Okay.
I'm gonna erase fix
Keep
this.
going. Doing good.
Okay, so P is equal to F of x squared minus x. We want to find P, the slope of the tangent, so P prime. Ooh, what rule do we have to use for this
Power
one?
rule.
What rule? Chain
It's the
rule.
same thing, right?
I didn't hear what you said.
Power rule.
No, that's.
Power rule is power rule. Power rule says
Power rule.
if F is, you know,
Wait, what
x
is
to the
power
fifth,
rule?
then F prime is 5x to the fourth.
Oh.
That's power rule. It's derivative of a function of power, yeah. So chain rule means you take the derivative of the outside times the derivative of the guts.
Hey, she used the word.
I did.
I was expecting.
Okay, we want this at x equals -1. So we get F prime of, 2 times -3. F prime of 2. Well, here's 2. What does F prime mean?
Slope.
Slope, right? So we want the slope at 2, which is down 2 over 1. It's -2. So you end up with an answer of 6. All right, how is that sitting with you? Feeling groovy?
Yeah.
Do you want to see what?
Scoring key.
The scoring key. Oh, you want to know how the points were distributed?
Yeah.
Oh, okay, I'll take 1 second to do that because
We need a stretch
one
like
big.
Wait, Randy. What was the answer?
Yes,
Miss Price,
yes,
Miss Price,
yes,
in the middle of class, can we take like a 3-minute stretch break?
sure.
Thanks.
No. You should walk. Okay, Brian? Okay, first answer, 1 point. I haven't looked at these yet today, so this is new. Now, this is the first time I've checked. 1 point for part A, 2 points for part B. 1 point for the answer, a point for the reason. Okay, all
So the
right.
answer would be like the interval, right?
The answer is both
Right.
intervals together. Okay. Part C, 3
Will,
points.
Will.
2 points just for finding H prime, and then a point for plugging in the 3. And then the last part, 3 points. 2 points for finding P prime, and then a point for plugging in the negative.
You get 2 points just for doing
The derivative? I know, isn't that nice? Yes, Andre.
You did the P prime of x wrong, and then you plugged in the 1 and got an answer, do you get the point for the answer?
It depends if you kept the nature of the problem or not, right?
If you, like,
So
forgot
say,
chain
for
rule.
example, you didn't have an F prime, you just had an F, then no, because you changed the scope of the problem, because they want to see if you know how to figure out the slope. So
But if I forgot like chain rule,
if you forgot chain rule, I don't know.
Time to drop out, you know?
Don't know.
Whoa. Right.
They want, you can make a mistake with a function as long as it doesn't change the scope of the problem. I don't know if leaving this off would be considered a change of scope or not. You'd have to, they do it problem by problem. All right. Okay. So, some people were asking me to do some homework problems. So I did 13 during first period today. We just scribbled it on there. It's not great, obviously not trying to scale. But I'm going to walk you through 13 and then we will walk through 15 together. But one of the things that people are misunderstanding is the limits. How to find the limits, how they come into play, all that kind of stuff, right? Okay, so this question said, find the area of the inner loop of r equals 1 plus 2 cosine theta. So our inner loop, this little guy in the middle, right? First of all, every time you can use symmetry to find area, it's usually in your favor to use symmetry. And the book, if you saw, they use symmetry like crazy. So it's almost always easier to use symmetry to do it. So for this one, we have to find what angle gets you here and what angle gets you here on this graph, right? So I know that this is the pole, so I would set my graph equal to 0, solve. right? So I've got 2 pi thirds and 4 pi thirds. And actually what happens is when you graph this, you come around, right? You hit this at 2 pi thirds, then you go this way, and you hit it again at 4 pi thirds, and then you go back around and you land back here at the end, right? So this is 0 to 2 pi, okay? So, we could go 2 pi thirds to 4 pi thirds on this graph. I'm gonna go 2 pi thirds to here and double. It makes me feel more comfortable. So, how do I know what point this is? Well, if I looked at my graph, I think that the R value is 1 here, but to me, if I'm not sure, well, I know 0 was over here, so let's try pi, because it looks like it's on the pi angle, right? It's either on the 0 angle or the pi angle, because it's on that thing, right? So anyway, so if I plug in a pi, I get 1 minus 2, which is -1. So it would be pi, -1, there's our angle, right? So this is at pi, this is 2 pi thirds. So if I go 2 pi thirds to pi and double it, that gives me my area. Oh, okay, hang on 1 second. I'm gonna tell one more thing and then I'm gonna go with your question. One of the things that we are misunderstanding about area is with polar, in general, I saw some students who were still trying to do top minus bottom kind of a thing, right? Area for polar it's not rectangular. It's literally coming out of the pole and it's doing little mini sectors. It's doing sectors. Oh, and I can show you how it's derived. Let's take 2 seconds and figure out how it's derived. All right. So, area of a sector of a circle. We showed you this yesterday, right? 1/2 theta r squared, right? That's for a great big, so that's a circle. Take out a nice piece of pie, right? Area of the sector. Okay, so r theta is just the difference between the angles, right? Okay, All right, so area of a sector. If we take the limit as theta approaches 0, the mathematical expression that represents the limit as theta approaches 0 is d theta, right? So if we took 1/2 r squared d theta, that would give us the area of a sector that's really, really tiny, right? Super tiny, it's like a line, right? And then, so if we've got now, instead of this, we've got some funky curve, and we're going from here to here. Well, now we take these little sectors, right? These are all little mini sectors, little pie pieces coming out from the center, right? So they all have a different radius, but that's okay because we're using a function for the radius, not a number. This has a constant radius, this has a function radius, right? And then the integral, of course, right? Start, stop. So the integral is what adds them all together, right? What angle do you start at? What angle do you stop at? The angle is just the angle that creates the first value, the first radius that you want. And then you move through until you hit the last radius that you want. First angle, last angle, the angles are not necessarily on the graph. And a lot of times what you'll see is they look like they're tangent. If you're not just cutting it off, if you want a full graph and it comes out, then you'll see the angles will be tangent at the point where you want it. Okay, what was your question, Meg?
Oh, I was just gonna ask, if you scroll up for a second. How you said that it hits the pole at 2 pi over 3 and 4 pi over 3. Could you say that, like, if you want to get halfway from where it starts to where it runs into itself again, you take the value halfway between 2 pi and 4 pi over 3?
Since it's symmetric, yes, you could do that.
Okay.
Absolutely. Because of symmetry, you could average those two values, get the one in between, and yes, that would work. Yep. Good. Other questions? All right, so let's walk through 15, and then I've got 2 really good ones for you guys. I know, yeah. Did you guys use Myers when you were younger, learning symmetry? No? They're so cool. It's just a little piece of plastic. You set it in like on any half picture, and then it will flash the other half when you
Yeah,
trace
I
it.
did use
I used to
that.
love doing that.
I don't
think I ever learned.
I don't think I did that. I don't think I did that.
All right, so anyway, 15.
What's that?
15 said find this area. The area between the loops, right? Okay, so what I would do if I was doing this problem is I would find the outer area, which would give me from the pole, so this whole thing is overall solid, right? Find the outer area and then subtract a loop area, right? Okay, so, and again, I personally would use symmetry. So I would cut it in half, do half the outer area, double it, and subtract half the inner area, double it. Okay, so we need these values to get the outer area and the inner area, right? This is actually the same function as 13. Did you guys notice that? Yeah, okay. All right, so we already know at the pole that this is 2 pi thirds and 4 pi thirds. So theta equals 2 pi thirds and 4 pi thirds. This over here, this is 0 and 2 pi. Now, you've got to be consecutive. You can't go 2 pi thirds to 2 pi. Because if you go 2 pi thirds to 2 pi, you're actually going woo, right? We don't want that. We want woo, right? So you can either go 0 to 2 pi thirds, or you can go 4 pi thirds to 2 pi. You want them consecutive. Do you understand what I'm saying? Okay.
Otherwise you get the low.
Otherwise you get
Then
weirdness.
you just like,
Yeah.
0 to the close one.
Yeah. Okay, so if we were doing this, so I'm gonna put, oh, here, wait, I'm gonna start with an area. So area equals, I'm gonna double everything I do. So 0 to 2 pi thirds. So 1/2 integral 0 to 2 pi thirds. I'm just gonna call this r, of r squared d theta. Minus, it's the same graph, right? It's the same r, so r squared d theta. Okay, so to get a little half loop, we figured out that this point, we just did it in the last problem, this point was pi, right, that angle. So I can either go 2 pi thirds to pi, or pi to 4 pi thirds. Either way, it doesn't matter. Numerically, you're gonna get the same value. Does that make sense? So it's really, it's the angle that produces the start, where you wanna start, and where you wanna end. So I'm gonna go 2 pi thirds to pi. 2 pi thirds to pi. And there's my area. Right? Okay, I mean, obviously I didn't do the problem now, haha, but I don't, so. Okay, all right. Okay,
No, like hers is good.
Yeah.
so today is really about arc length, but we're gonna focus more on area and just a little bit on arc length. So I want you guys to take a few minutes. See if you can set, this is calculators permitted, right? See? Right, okay. So I want you guys to take a few minutes, graph this, see where the area overlaps, and see if you can write an integral or integrals that will give you that area. Then use your calculator to integrate. You don't have to integrate by hand.
Yeah, they are.
Oh, okay.
Wait, sorry. How'd you do? I probably.
What, how do you got ratings?
Still. Still.
Oh,
It's
fine too, and then you go, I can't say that.
Really? I'm hearing a lot of mixed reactions to it. Yeah.
No, why did it turn out 50%?
You got 51.
What the hell, isn't that bad? How many
I
questions?
heard there was a lot of stacks. Yeah, there are.
I'm pretty sure I got a 50.
Oh, on the SBA.
Pretty
Yeah.
okay on
What'd you get on
that.
this?
Yeah.
I'm so.
No,
I'm so happy to watch second semester is fun.
Real, if I can.
Doesn't give
No,
me
it was like,
It's
which of these points will I?
Dude, he'll probably curve it a ton.
It does.
Oh.
Is
So I
it good?
plugged into my list and then do like
It was
one
pretty
variable
subpar.
stat to find
Right,
it.
Find it, yeah.
Like what?
Yeah.
You saw it like. Touch it. Face is right there.
Okay, I'll be the mediator.
You're the communicator here.
Okay, I got 60.
Now you will.
Don't be fun there. I got you, sorry.
Where's she at?
Okay.
Yeah.
Now, say something nice about it.
I would like pay on that.
Hey, leave.
I wouldn't.
Say that we'll have a nice thing.
It's got 55 out of
Wait, what did
58.
Brian do?
Right.
Hey, everybody, we're trying to be nice here.
Ryan,
What did you
hey,
get?
Ryan,
Well,
what
I
high
think
school?
All right.
Hey, I heard it from his mom.
What?
That's enough. That's
Ryan.
enough. Back to work, back to work, back to work.
See the Come on.
Whoa. Oh, okay, yeah. Okay, so 3 concentrated is. Whoa.
That's so beautiful, that choke test.
That's the worst. What's the next? Is it 5 pi over 4? That's in the 3 quadrant.
Yeah, so it's perfect.
So then, cosine over sine, did you get cosine pi over 4 is cosine theta is 1.
So just plug it back in.
Or you could do just wait, dude.
I have 4.
No.
Good.
You can just plug it to get the 2 points.
If you're stuck, let me help you get a little nudge.
No.
First of all, did you find the point of intersection, pi fourths?
Yeah.
Yeah. Wait, is there?
Not yet?
Aren't there
Okay.
2?
Wait, why would you do pi?
But it's also, but I'm just looking at this one, I mean.
There's
Oh,
another.
true.
Is there? No, there's
Okay.
What am I doing?
Alright, so let's talk about that, right? If we need both of the points of intersection from 0 to 2 pi, because if they intersect again at 5 pi fourths, what ends up happening is you get a negative for both of them and you're right back at the same point,
Oh,
right?
okay.
So if you don't really need it because it's
This-
redundant,
That's a
right?
good word.
Okay, so, oops,
How do you know if it's redundant or not?
well, because you're in the exact same spot. So here's what, okay, first of all, would you use symmetry on this one?
Yes. Of course.
Whenever you can use symmetry, you should use symmetry, right? So we're finding this area, so if I graph theta equals pi fourths, right? Could I just focus on the black circle and do from this angle, its starting angle to pi fourths and double it, right? I could do that, or I could go from here to here on the pink circle and do pi fourths to whatever that is and double it, either way. But I would not do the whole thing because then you have to do an integral with the sine function plus an integral with the cosine function. So if you can avoid that, it's much easier to just do one and double. Right. Try it, see if you get your setup.
How would you do it if you if you couldn't double it?
Then you have to add them together.
Okay.
Yep.
Yes, Bryce.
Yes.
Can you just like give like a brief thing on the angles and just like be on that?
Sure, sure. Okay. So say I'm focusing on this top circle, the black circle,
Yeah.
that's the sine graph,
Yeah.
alright? So I wanna go from here to here
Yeah.
on this graph, right?
Yeah.
I need the angle that gives me the pole. So the angle that gives me the pole on the sine graph is where this equals 0, which is at 0,
Yeah.
right? Okay, then I need the angle that gives me this point. Well, this point I actually found by doing points of intersection.
Yeah.
So once I get my angle that gives me the starting value, the next consecutive angle that gives me the next point I want, I just go from there to there.
Oh yeah.
Yes. So just think, I want the angle at wherever I want to start to the angle wherever I want to end. Now, and be careful, because you don't want to go to 5 pi 4s, because then what you're actually doing is you're going whoop, right?
Yeah.
And it's going to get messed up. So yeah, you want to go consecutive.
Wait,
3 sine
I mean 3 sine omega.
theta.
Stop saying omega.
I don't know why I keep calling it omega.
Yes.
Omega.
Okay.
Or you could go pi versus pi halves on the circle, use cosine.
How's the grade looking though?
I don't, it didn't change it all for me.
Fine, well, 3 sine
It
theta.
wasn't B minus, it's still B minus, but there's no way it's still B
Yeah,
minus.
because I got 3 sine theta. I just saw it here.
What?
3 sine theta.
Yeah, it's
so 9 pi over 8 minus
You have it covered?
yeah, I have a B plus, I'm so happy.
Yes.
I'm always sleeping in the shower.
No, it's always.
Unless I go to the bathroom and second wake up and walk.
Well, and that's kind of where that direction orientation comes in.
I know that
The
is
order
so
that it gets
fun.
right.
Okay, so you
I need to stretch break like right now.
It's okay, the AP test is based on it.
It is a curve, get it? It's based
Ah. The price is right.
Price is a legend.
Okay,
Yeah.
alright,
Price
so,
is right.
so for this
Oh
one,
my god, that's mine.
so
Brian.
we either have, I did integral 0 to pi fourths of the sine graph, right? You could have done pi fourths to pi halves of the cosine. Same kind of thing, you would have gotten the same answer, approximately 1.284. Okay. All right, you ready to take it up a little notch?
3.79.
Okay.
Oh, wait,
Yeah.
Or no, I mean,
Okay.
You know what's
Up,
really
up, don't look.
It's not that hard.
Hang on.
Oh, really?
Never close your eyes.
It's not that hard. It's hard.
I got some, yeah, get bored.
Yeah, can you want
Alright.
my percentage, Brian?
So,
51.
one of the things that actually helps me a lot with this is making the graphs like big on the window. That graphing window, when the graphs are squished, it's hard to get a good feel for what you need to do, you know? I like to have them as big as possible on the window, and then I usually will transfer them to paper so I can really look and see and figure out what I need to do with the graphs. So anyway, try to graph both of these, get them as accurate as possible. See if you can figure out what you need.
These are my sleepy pills. That'd be a good idea. Wouldn't that be great? If you could just like, you know,
Wait,
like drive
where
it,
is,
and you could have.
oh, okay, so you, but you use the wrong angles, right? If you're, because 0 to pi fourths on the cosine graph doesn't give you the right tangent. Remember, you have to do, if you were, can I draw on you? Yeah. Okay, so if you look at your graph,
I'll get
you
them from like the
had,
last day. Last day before we did all the test back.
and then you had
After grade
here,
30.
right?
Yeah, grade through line.
Okay, the top graph is the sine graph. This is the area we want, right? So there's pi fourths, right? If I go 0 to pi fourths on the cosine graph, pi fourths on the cosine graph is actually, let's see, it's here to here, I'm getting like this big giant space. This is
Have you
pi
done, like, any-
fourths,
Yeah, I think
but
I have
0,
I only have 10 points in
cosine
grade, but I might
is 0
be in my
at
and I feel
pi
like it's something else.
halves. So this is actually the point pi halves 0. The angle 0 on the cosine graph is actually
We'll
out
have to
here.
read it today.
Well, yeah.
So I'd be going from
No,
here
no,
to
you
here
gotta-
and getting
Is there,
that
is there a
area.
test or a quiz on it?
Yeah.
If you did 0 to pi fourths
It's not
on the
that,
cosine
it's not that
graph.
bad.
Like,
Okay, well, and what do you?
Put your
I know
right
it's
here,
all
like-
the-
So for the cosine graph, remember, you've got to find the angle.
I don't know about that. I read like one page every
It only
day.
looks at, it only looks at like 3 look
To here.
like, okay, was the majority of the book
Cosine
about
graph,
gay
we go,
rights?
remember, the graphs go
Yeah, so
this
you
way,
got one with
right?
like the.
Right, if you were to graph it slowly, right, it would go this way.
And I also have a
Not
very,
this
very,
way.
very minor kind of.
Graphs in
It's not really,
general.
it's a physical
Yeah,
distance now.
remember we talked about orientation? So this graph goes, like the orientation.
No, it is,
right
like I
there.
just tried to read it
It's
here.
like that.
And then my red eye stuff.
Okay, so here's the thing.
Yeah.
No, my
Cosine
red eye
theta is
freezes
zero.
never left it.
Cosine theta is 0 here. So that's what we want to know. Cosine theta is
I'm
0.
95
This
right
is
now.
actually the angle pi halves for cosine.
It's really nice.
In radians, the
Well, I mean,
this is the
I mean,
angle
Oh.
0.0 pi
cosine is
halves
Hopefully I'll go to the.
on the cosine graph.
Yeah.
So since this is this pi fourths, I'd be going pi fourths to pi halves to get this.
Oh, you're right, so you don't need the worst case scenario, I'll just start.
First write a letter.
That's what I'm telling you. Find a point of intersection.
Did your brother?
Okay, so I need to know where the pole is for cosine, so set it equal to 0, so if you know where it's at.
Cosine's gonna make it.
I don't know what to write about though. Like, none of them got.
Oh, you're looking for theta.
I was wondering why
Pablo
everything
never.
Dude, write about
I have kind of someone.
And it was about.
and how.
Yeah.
I was gonna write about social. I was gonna write social
Because you
concept,
are
but you
starting
realize it's not really.
Yeah.
social.
Right about how they move like 9 of the prisoners to Saudi Arabia.
Bruh.
Towards, right?
Bruh.
And you're ending.
Did you hear Amon broke up with his girlfriend?
What?
Amon broke up with his girlfriend? Yeah, I didn't even know.
I'm sure it's
I didn't know, I found out yesterday. Elise told me.
No, it's not Reddit.
Dude, yeah, he did a while ago.
Order doesn't even
Wait, the
really
actual
matter.
name
I'm just telling
I
you.
don't know.
I feel like it's.
I want
see
this
anything about
point,
it.
this
I
point,
think I
and I
got
want
her name
this
was
point
Tina.
over here.
What's it?
Then you need to find the angle that gives you this point.
Tangent?
You need to find the angle that gives you
Okay.
this point. You can't assume just because it's the pole that the angle is
Is she
0.
hot?
It's just because the radius is 0.
She's hot.
So that's a new set.
Wait, so do you have to do anything
To
to
0.
symmetry here?
Yeah. 9. Yeah. So you Oh,
Sine, when we did sine, the reason we could do 0 to pi fourths is because the sine of 0 is 0. So this was the point 0,
or
0.
write about the 25.
I need a woman on the screw angel
Right?
trail tier.
Oh, you go from that certain half to certain.
It was, do you want a decimal or an exact?
Oh, you wanna go from here to.
100.
But is that the symmetrical on both sides? I don't think that's. Up and down.
9 pi 8 minus 9 fourths. Okay?
What do you say?
Good. Who else needs some help?
I need some help.
You need some help?
What'd you get
So-
for your angle?
I found theta to be 2 pi over 3.
Wait,
So
is
those
the,
are your points of intersection. Okay.
is the intervals
I got
2 pi with
Right, and we're gonna use symmetry, right?
Okay. So
What you got for your angle? We're laughing at oval
Think of one half.
Yes.
So then how would that?
Well, I need the space from here to here, right?
Oh, so it's 8 counts.
No. That's 2 pi thirds. You're not, we're not, don't think vertical, horizontal, from the center around, right? So what you need to decide is from here to here, what graph are you on, and then what angle on that graph you point. And then from here to here, what graph are you on, and what angle gives you beginning and ending point for that region.
So I find R is 0 here.
Uh-huh.
So I set.
On whichever graph, you have to make sure you're on the right graph. Okay? And then do that
So it's like
there.
4 different sections, I guess.
And then from here to here, you're on the cardioid, and you need to figure out what angle that is on the cardioid.
So it's like, okay, and cardioids are that like constant?
Yes, yes. Yeah, the 2 minus 2 cosine theta is the cardioid.
And is that radius 4? Yeah.
All right, I want to give you another quick lesson. It's okay. All right, off to the side. Do you guys remember when we did areas in rectangular coordinates? Say you had some curve and then a different curve, right? And say I wanted the area from here to here. Well, I can't just do one integral. There's no way. I would have to do an integral from here to here with that curve, right? And then a second integral from here to here with that curve, right? Okay, let's take a close look at the graph of what we have here. Hopefully you all got that this is 2 5/3. Right, did you get that that's 2 5/3? Okay, so we're talking about this region, right? Overlapping? Can we use symmetry?
Yes.
Yes, because it's symmetric over the x-axis, so the line theta equals 0. Okay. All right. Watch carefully. Okay. Now, I want to start here. I need to follow the pink curve to here, right? And then I have to follow the black curve to here, and then I stop. Does that make sense? Just kind of slowly tracing the outer boundaries. Are you with me? Okay, so here's what you need to ask yourself. For the area with the pink curve, what angle do I need for it to be here? And then what angle do I need to be here, which I know because it's 2 5/3, right? Then for the black curve, which is the cardioid, I know I'm starting here, and then what angle sends me here, right? So it's start to finish on the pink plus start to finish on the black. Okay, so you have to figure out what this angle is on the pink, and you can kind of think of it like this. It's like the sliver plus this guy.
Got it. It's gonna be kind of.
Oh, because it does. It all comes out from the center. Always comes from the center, right? So you get that for the pink, and then from the center for this guy, right? It's always from the center.
Oh.